Today, we're talking about structural degradation, the slow rot that happens to your data's shape over time. This isn't a dramatic outage or a single bad deploy. It's the quiet erosion of guarantees and clarity that accumulates as systems age. By the end of this video, you'll know what structural degradation looks like, why it slowly destroys trust and productivity, how to spot it early, and practical habits that slow or reverse the decay. Let's start with an intuition. Structure is a promise. Fields will be present, identifiers will be stable, types will mean what they say. Structural degradation is when that promise weakens. Maybe a field becomes optional, or its semantics subtly shift. Maybe new optional fields creep in, and nobody documents them. Over months and years, those small changes add up until your data is harder to use. Tests fail more often, and onboarding new analysts becomes painful. Here's a simple example. A user entity once had 3 fields: user ID, email, and created @. Teams added optional profile fields, a mobile prefix, a preferred name, and then a partner integration started sending user ID as a string sometimes. Slowly, downstream code accumulates special cases. If user ID is string, cast it. If email missing, look up via OAuth. If preferred name present, use it for display. Each special case is sensible in isolation, but together they create a fragile web of conditional logic. That's degradation. Why does it happen? Several recurring causes. First, organic evolution. Teams add fields to solve local problems without coordinating changes globally. Second, API and vendor churn. Third-party schemas change, and you accept their variations without consolidating. Third, inadequate validation-at-ingest. If you don't assert what's essential, optionality becomes default. Fourth, accumulated technical debt, quick fixes, hot patches, and undocumented migrations. And finally, entropy. Systems naturally move from ordered to disordered, unless you apply maintenance. What's the harm? Structural degradation increases cognitive load. Engineers and analysts spend time inventing transforms instead of answering questions. Automated pipelines become brittle and expensive to maintain. Models trained on semi-consistent features lose performance. Worst of all, trust in data erodes. Folks stop relying on dashboards and start trusting spreadsheets or manual reconciliations. So how do you detect structural degradation before it becomes a crisis? Start with baseline metrics and a decay mindset. Measure structural health, not just pipeline uptime. Track field-level presence and type distributions over time. A slowly rising null rate for a critical field is a red flag. Monitor value entropy. If a low cardinality field's distinct values balloon, semantics may be drifting. Watch for growing counts of conditional logic in downstream code. That's an organizational signal more than a metric. Track schema churn. How often do producers change field names, types, or optionality? And importantly, surface lineage so you can see which upstream changes ripple downstream. Some practical detection checks. Daily schema profilers that report presence, types, cardinalities, and sample values by source. Alerts for sudden or steady trends in missingness or type mismatch, and lightweight health scores per domain entity that combine these signals into an at-a-glance indicator. Once you detect degradation, how do you respond? Think maintenance, not emergency surgery. Focused, first. Prioritize, focus on entities and fields that matter for business, KPIs and models. Second, consolidate a canonical model for those critical domains, a minimal, authoritative shape that teams agree on. Third, automate normalization at ingestion so consumers see consistent shape even if producers vary. Fourth, schedule cleanup and refactor cycles. Treat structure maintenance like dependency upgrades, put it on the roadmap and allocate time. Engineering patterns that slow degradation are straightforward but powerful. Validate at the edge. Assert required fields and types at ingest and quarantine records that fail. Version schemas and role changes out with migration plans and compatibility checks. Keep raw, immutable event logs so you can reconstruct authoritative state later. Provide shared libraries for serialization so teams don't invent slightly different formats. Add contract tests in CI between producers and consumers, so incompatible changes fail the build, not production. Operational and organizational practices are equally crucial. Adopt a data-as-product mindset. Assign owners for core entities who are accountable for structure, SLAs, and compatibility. Document minimal examples in a lightweight catalog with sample rows. Humans read examples faster than schemas. Schedule periodic data maintenance sprints to remove deprecated fields, consolidate similar attributes, and eliminate hacks. Treat migrations as multi-step processes with dual write windows and rollback plans. Also manage lifecycle explicitly. Some fields are naturally ephemeral, don't pretend otherwise. Establish retention and archival policies and make them visible to teams so nobody assumes historical completeness where there is none. There are also defensive monitoring habits that pay off. Track time to entropy, how quickly a new field becomes used inconsistently. Set alert thresholds, not just for spikes, but for slow trends. A 3% monthly drift in completeness is meaningful over a year. Capture developer pain signals. Frequent support requests about a dataset often indicate hidden degradation. Finally, accept that some degradation is inevitable. The goal is to manage it. Create processes that make structural evolution deliberate rather than accidental. Small, reviewed changes with migration plans, validation, and documenting intent. To wrap up, structural degradation is the slow corrosion of the promises your data makes. It starts small, a missing field here, a type mismatch there, and compounds into large maintenance burdens and loss of trust. Detect it with field-level health metrics and schema profiling. Slow it with validation-at-ingest, canonical models, and shared libraries, and institutionalize maintenance with ownership, sprints, and clear life cycles. When your data's shape is intentionally managed, your analytics, models, and teams become faster and more confident.